Spark. Actually, Spark is is developed as an alternative of the MapReduce. What
Yes,
is the
sir.
purpose of the MapReduce component, Teja?
To the purpose of MapReduce is to reduce the amount of time taken to process files.
Correct. The purpose is to processing the data, to
Yes,
processing and gives the output.
yes, sir.
The purpose is processing, means data is available on the HDFS. So as the raw data is available, so we need, as per our business requirement, as per our show record requirement, we need to pick the data from the HDFS and process it as per logic and gives the output again onto the HDFS.
Okay,
Right?
sir.
So purpose is processing the data, processing the data. In the same way, they have come up with a Spark. Same, it is a Spark is also, it is also a processing engine.
Okay.
Processing engine. Spark is called a processing engine which is developed alternative of the MapReduce. Parallel. What is the purpose of the same MapReduce? Same purpose is the Spark also. But
Okay, sir.
while what is the main core difference between the MapReduce and Spark is it is almost 100 times faster than the MapReduce.
Okay.
Not 1 or 10 like that. 100 times, almost 100 times faster, only faster.
Faster.
Nothing else. Whatever the logic we have mentioned, the output comes as per that only, wherever, right?
Okay, sir. Okay.
So, see, A equal to B plus C. So what we are doing here, summation, taking the B variable, value of the B, taking the value of the C, and we are summing, adding it and assigning it to the result to the another variable C, C equal to A plus B. Same,
Yes, sir.
it will be done like that. It will be done in the Spark also. Whatever the logic we have mentioned is A plus B, that is. So our output comes out as per our logic we have implemented. That is, it doesn't matter, same, right? But
Yes.
difference is fast. It gives that if it takes the 10 minutes for MapReduce, 100 minutes, Spark it takes the only 1 minute.
Okay. Pig is also
Pardon?
Pig is also like that only, no?
But pick very limited transformations. Whatever the transformations available, that only available in the pick we can use, right?
Okay.
But use volume of data, use volume of, that is the drawback I have told you at the peak, right? So it is very small business pieces, it will be applicable. It will be this one. Otherwise, if it is a use business and a use logic, PIG will not support that much level.
Okay, sir.
And again, PIG is built on top of the MapReduce, but Spark is not built on top of the MapReduce. Spark is built, has been built separately. It's not at
Okay.
all related to the MapReduce.
Oh, wow. Okay.
PIG is built on top of, so whenever we are executing a PIG job, internally MapReduce job only will be executed, right?
Okay.
But Spark, it's not related to the MapReduce. It is a very separate from the MapReduce component, and it is very faster than the MapReduce.
Okay.
Just 1.5 years back only Spark into the coming into the picture, because Spark is built on the labs, but just they have released 1.5 2 years back only.
Okay, sir.
As per my concern, only a single digit production, a single digit of customers are having the Spark in the production.
Okay.
So even my customer is also having, my company also, we don't have any Spark in the production. Just we are at the POC's level, means we are POC, you know, right? Proof of concept.
Yes. Yes, sir. Yes.
So means before getting into the actual real-time project, we will do the some trial and errors of the Spark, how we are reading, how we are developing, and some QA environments we will take and productions. Like that we will sampling it.
Okay, sir.
So most of even my friends or some other companies working on Hadoop, they are also in the Spark POC level, not in the production level.
Okay.
Okay. So means recently it came up na where means some Google like that, some companies Cisco are in the having the production Spark in the production level.
Okay, sir.
Okay, Cisco, Google like that. So this is Spark difference between the Spark and MapReduce at a high level. Getting into the depth. So how data will be stored in the MapReduce and the HDFS?
On HDFS, we'll just get from Linux and store it
Means
on
in
the
the form of blocks, right?
in the blocks. Yes, yes.
This simple straightforward answer is for us here. Data will be stored on the HDFS in the form of blocks.
Okay, sir.
From there, MapReduce accepts. Just here I will explain you Spark with compared to the MapReduce. Then it will be easy for us. Okay.
Okay, sir. Go ahead.
Okay. Now see one similarity between the MapReduce and Spark is MapReduce also accepts the data from HDFS. Spark also accepts the data from HDFS. There is no difference in the storage area.
Okay, sir.
Storage HDFS and LFS.
Okay.
HDFS and LFS storage component and all other components remains the same. Only
No difference
for
between,
processing the data. That's it.
not like MapReduce.
Correct. Just it is all other things are same. Means it takes the data from HDFS and keeps it on the HDFS. All the things are the same.
Okay.
Only if you want to run the Spark, if you want to execute your logic on the MapReduce or Spark, you can decide. That's it.
Okay, sir.
So same storage area, there is no difference on the HDFS and there is a LFS.
Okay.
Okay?
Okay, sir.
No.
Okay.
So in the processing, just it will, first I would like to tell you about the architecture. Before going to the processing architecture, I will tell you. Okay. See, same cluster, everything same. We can use the Spark on the same cluster. Okay.
Okay, sir.
Terminals are different. That's it. Same driver.
Worker
Here,
node executor.
yeah,
Okay.
here we can, in the Spark, this is the cluster manager, this is the driver program, these are the worker node. We can relate, right? Worker node means nothing but a data node.
Okay.
Okay, means we have n number of data nodes, right? Slave nodes.
Yes, sir.
This is worker node. Actually, in the MapReduce, how we are taking the general data nodes and right?
Yes. Storing in the data node.
Same, we have in the same slave node, we have worker node. Inside the worker node, we have executor. Executor nothing but a just JVM. That's it. JVM process, Java Virtual Machine.
Okay, sir.
In our technical terms, we can say JVM. Means, but in the Spark terminology, we should not say JVM, but it is a JVM.
Okay, sir.
So JVM, what JVM do is Java Virtual Machine. It executes the tasks, right?
Yes, sir.
So each executor is
Yes.
having a task, n number of tasks. To it execute, JVM executes those tasks.
Yes, sir.
This diagram, you are able to see my this diagram, right?
Yes, sir. The worker node executor is only, no?
Correct. Worker node,
Yes.
executor. Worker node is having, each worker node is having each executor, means one worker node having one executor. Under that executor means executor nothing but a Java virtual machine.
Okay, sir.
So each JVM is able to execute the n number of tasks like this. So each executor can have tasks like this. Okay.
Okay, sir. Okay, sir. Got it.
Then now cluster manager first contacts the driver program. So from as from the driver program, it takes the data of the worker nodes, means metadata of the worker nodes, and send the request to the each worker node.
Okay.
See, first cluster sends the contacts the driver program and takes the metadata of the each worker node and takes back the worker node. Okay.
Okay, sir.
Cluster manager contacts the driver program to take the metadata of the worker node. Then only it will contact, right?
Yes, sir.
So once it takes the metadata from the driver program, then it contacts the each executor like this and takes the output back.
Okay.
This is a high level architecture of the Spark.
Okay, sir.
Understand what it contains? It contains the cluster manager, driver program, and worker nodes. Each worker node is having a separate executors in it. Each executor nothing but it's a JVM.
Okay,
In
sir.
the
Got it.
we can say it as a JVM, Java Virtual Machine, Java process, JVM process. So
Okay.
JVM process can execute the n number of tasks.
Okay.
Got it?
Got it, sir.
So this is the high level architecture of the Spark. Okay.
Spark. Yes, sir.
Okay. Even programming also at a high level I will give you, Tej. Okay.
Okay, sir. No problem.
Yes, I will execute the program at basics level, basics. Okay.
Okay, sir.
But as I told you, it is 100%, 100 times better, faster than the MapReduce, means we
MapReduce.
cannot avoid the MapReduce program, Teja. Very, very important at the first entry level. MapReduce should not avoid it. Okay.
Okay, sir.
Because all other Hive, HBase, Scoop, all are based on the MapReduce only.
Okay.
So please don't avoid the MapReduce.
Yes, sir. Basically,
Just knowledge, keep in the knowledge about the Spark. Whenever there is a chance to work on it, it will be useful.
yes, sir.
Okay.
I mean,
Now,
you're saying for practice sake only, no, sir?
pardon?
You're telling for practice purposes, no? Like
Correct,
don't.
correct.
You're saying don't, avoid MapReduce and all.
Yeah, perfect. Now, so how it see as it takes the accepts the data from the HDFS and processing it and keep it on the HDFS, then what is the advantage of the Spark? Why it is 100 times faster than the MapReduce? Why means, see, always MapReduce goes to the HDFS and takes the data in all the 3 pages: mapper page, where mapper keeps the output, Teja.
The mapper, okay, wait. Mm, you mean the mapper program where it keeps the output?
No. Forget about the program. We have 3 pages, right? Mapper
Yes,
phase, sort and shuffle phase, reducer phase. Phases.
yes.
Mapper takes the data from the HDFS and process it, and where it gives the output, where it keeps LFS.
Mapper takes it and puts it in the LFS. Yes, sir.
Able to recollect it, right?
Yes, sir. Yes.
And
I mean, I didn't get your question, sir. That's all.
Huh?
I didn't get the question. I mean, I misunderstood the question.
Okay, I will show you where it is, that one.
No, sir. Don't. I mean, no need of that. I'm just saying that the question I did not get at first.
Okay, now you got it.
Now I got it, sir.
Okay, so mapper takes the data from HDFS and processing it and keeps it in the LFS. Again,
Yes.
sort and shuffle takes the data from LFS, means it has to go to the LFS. We have 100 n number of nodes are there. Every LFS, it takes the data. Every sort and shuffle has to go to the LFS area and takes the data and process it, and again where it keeps LFS.
LFS.
Again, reducer goes to that particular LFS, takes what I am explaining is internally happening. Framework is taking care.
Yes, sir.
Okay. Now reducer goes to the LFS, takes the data and process it and keeps it on the where?
Reducer takes it and keeps it in the HDFS.
Correct.
No.
So
Yes,
total
yes,
two HDFSs. First
yes,
input and last output.
yes,
In
yes,
between everything on the LFS.
yes.
Got it?
Mapper's output is in the LFS and then HDFS output is in the reducer output is in the HDFS.
Mapper out, not output. Mapper input takes the from HDFS and keeps it on the LFS.
LFS. Yes, yes.
Mapper input and reducer output only on the HDFS.
HDFS. Okay, sir.
Mapper input, reducer output.
Okay, sir.
That I have explained in the with the diagrams. Teja?
Yes, sir.
Okay. Now what Spark is doing is, so here you can observe always it has to go to the data the storage area and retrieval and process it, right? Always in all
Yes.
the pages.
Yes.
In all the pages it has to go to the storage area. It may be HDFS, it may be LFS.
Okay.
But it has to go to the storage area. So it takes time, right? For engine, MapReduce engine.
Yes, sir.
But in the Spark, how it addresses, once it takes the data from HDFS, it keeps it in memory.
Okay.
Whatever the file, terabytes of, gigabytes of, whatever the, how many blocks are there in the HDFS, how many blocks, how many terabytes of data is there, whatever the input data is there, it takes the required output at once. Spark takes the required input data. Spark takes the required input data from HDFS at once and keep it in memory.
Keeps it in memory. Okay.
In memory. Spark engine has its own memory.
Okay.
See, whatever the, even Java program, C Sharp, or whatever the programs, there is a called discrete cache. You know, cache memory. Have you about the cache memory?
Yes, sir.
What is cache in general? Not about the, forget about the Hadoop. In general, either C Sharp, Java, C++. What do you mean by cache, Teja? Any idea?
Cache is like data stored, like temporary storage for speeding up the processes, if I am to understand.
Exactly. In the general Java or C Sharp, what we can do is, for any small information is there, first we will take the data from the any RDBMs, any database, and keeping it in the cache, then we can reuse it in further, right?
Okay.
Every time to database means once we are going to database and pick the database happening, it consumes the time.
Yes, sir.
Hope you are getting my point.
Got it.
So instead of going to every time to the database, it keeps thus, as it is a small data, it keeps it in the in-memory, cache memory. So that whenever that data requires, it no need to go to that particular database, it reuses the data which is available on the cache memory.
Okay, sir, got it.
This is happening in our regular web applications.
Okay.
Coming to the Spark, in the same cache memory, it has very huge volume of the cache value. So that is the intention. That is the advantage of the Spark. That's why Spark has been built. How it has been built is, it takes the first at one time. It takes the input file from the HDFS and entire input data keeps it in cache memory. That much cache memory Spark has. So once it has in cache memory, no need to go for the HDFS, no need to go for the LFS to keep or whatever. It processing it, entire logic. Once everything is processing done, 100% done, then it keeps it on the HDFS at final result.
Okay, sir.
In between, so if MapReduce, so many interactions with the HDFS and LFS, whereas Spark only one interaction takes the input from the HDFS. That's it. It will keep keep the entire data in that cache memory.
Okay, sir.
So once it has the entire data in the cache memory, whatever the processing we are doing the logic, it is applied on that data only. Then final output will be kept on the HDFS.
Okay, sir.
That is the advantage. That is the beauty of the Spark basically.
Okay. So
So how it is faster than the MapReduce? Can you please summarize, Teja, if you
it will
understand?
keep everything in the cache memory.
Yeah.
So because,
And you, yeah,
but
go ahead.
still cache memory is, everything is internal. If you have a large amount of cache memory only, you can use Spark. Is it right?
Correct, correct. It will be there. It will be there. Correct, correct.
So normal systems won't be able to run Spark then.
Normal systems means normal Hadoop cluster is having the only internal memory means you should provide the RAM itself. That's it, right?
Exactly, sir. Yes.
Yeah. So it will take even production in the production RAM will be high definitely.
Oh, okay, sir. Okay. No,
Whatever
I
you are
understand.
having the normal Hadoop cluster, that is enough.
So it will be temporary. Whatever it is happening, it will be in the temporary cache memory. Sorry. So because of
Correct.
that, it's faster.
Yeah, once a job is completed, that will be another job, right? That cache will be removed. That data will be removed from the cache. Once it job is completed, done.
Yeah, Sridhar. Yeah, I got it.
So that cache memory is not permanent. Data will not be resides permanently on the cache memory. Only for that job only, that memory will be resides on the cache. That data
Okay.
will be resides on the cache.
Got it, Sridhar. Got it.
For the next job, it again fresh.
Okay.
Getting?
Got it, Sridhar.
Okay, just hope you are having total picture on the Spark engine.
Yes, yeah, Sridhar. I'm slowly understanding. Yes.
Cool. Now we will get into that details now, practical details. Okay.
Okay, Sridhar.
Means at a high level, what is you are able to explain what is the difference between Spark engine and MapReduce engine?
Yes, Sridhar.
Because it keeps the data in memory, no need to go to the always storage area, either HDFS or LFS, because that is the time consuming basically, going to the HDFS, going to the LFS, keeping all. So Spark avoids that one because it keeps the entire data in memory called cache.
Yes,
In
Sridhar.
memory, where cache also called as in memory, IN-MEMOR, in memory.
Okay, Sridhar.
Okay, so
Yeah.
that is Spark engine behavior. Okay, how it implements. So now coming to this practicals. For this, I am using this Cloudera Quick Start because I did not install because Spark needs to be installed, Teja.
Sparks needs. Okay. Okay.
So because whatever I have given this, so you Ubuntu 10, all these things, I have installed Hive, Scoop, HBase, all these things, but I don't have the Spark in this one. But Cloudera Quick Start already you have, right?
Yes, Sridhar. I have.
Cloudera Quick Start VM 5.7.0, this version or any other version?
I have a Cloudera VM 5.5, Sridhar.
Yeah, maybe it has also. Just try to open and see that one. By default, they are giving us the Spark. I don't no need to install, right? So I am using this VMware, Cloudera VMware. Okay.
Okay, Sridhar.
Okay. Now just minimize it. One more thing I need to RDDs. I need to explain RDDs. Okay. Uh, 1 second before this one. Before I need to explain. And some terminologies we need to mention. RDD.
What are you doing, Sridhar?
Yeah, RDD. I will tell you what.
Okay.
Okay. There is a concept called RDD in the Spark. Okay.
Okay.
So
Resilient
one
distributed data set.
exactly correct. You know about the RDD?
Little bit, Sridhar.
Okay. What do you know? Just can you please summarize it?
They are just like dummy computers which have no other use except for cache memory.
Yeah, it's a correct. So resilient distributed data set. So
Yes.
once it takes Spark engine takes the data from the HDFS and it keeps it in memory in the form of RDDs.
Okay.
Okay, so data will be available on the cache, Spark engine cache means in memory in the form of RDDs, resilient distributed data set.
Okay.
RE, what is spelling RESILIENT, right? Just correct me if I am wrong in the
No, no.
spelling, okay?
You're good, Sridhar. You're good.
Resilient, distributed, distributed data set. Okay, resilient distributed data set. So data will be stored in the form of RDDs in the in memory of the Spark engine. Now, so RDD is a immutable. We can say immutable. You know immutable
Immutable.
means not changing,
Okay.
not changeable. Means we cannot change. Once RDD has prepared, it cannot be changed. It's a immutable. Means
Okay.
string builder. String is a immutable
Oh yeah,
string.
yeah. String builder is mutable and string is immutable. Yeah, yeah, got it, Sridhar.
Correct. In such a way that resilient distributed data set is the immutable. Okay.
Okay.
So in the here one more important point. One more important point. Spark is a engine. Okay. Spark
Okay.
is a engine. There is a programming scripting language. So here we need to write. So as a Spark engine, it processing it by using the in-memory, right? In-memory concept. But
Yes.
we have to, in the map reduce, we are writing the business logic in the mapper class and reducer class
Yes,
and
Sridhar.
some partitioner classes. We have some Java classes are there. We
Okay.
have some Java classes are there to write the our logic as per our business requirement. In the
Okay.
same way, Spark is the engine to process it, to keep it in memory and processing it. But we have to write our business logic also, right?
Yes, Sridhar.
We have to write our business logic. Where we are writing is a challenge. Where we are writing in the map reduce, there are a separate class Java.
Okay.
But here we have a challenge where we need to write. For that, they have provided one scripting language called Scala.
Okay.
This is the Scala is heard about the Scala earlier?
Yes, Sridhar. It is for Spark, right?
Yeah, correct. Scala is a scripting language where we can write our business logic
Okay, Sridhar.
for Spark.
Okay. Okay.
Scala is a language where we can write the
Right.
business
Business logic
logic
for
for
Spark.
the
Spark.
Spark.
Yes, Sridhar.
Cool. Now, so we can declare the RDDs and we can take the data from HDFS and keeps here everything on the Scala by using the Scala scripting. There is syntaxes and some same something is available on the Scala is a language. Okay, scalable
Okay.
language. They can say scalable language. That's what they have introduced with Scala.
Okay, Sridhar.
Cool. Now coming here. This is my, so I am minimizing it. Okay, cool. So again same, I can open the terminal here. Using terminal, we can go for terminal here, here or here, both. Okay.
Okay, Sridhar.
Opening the terminal. Okay. Same, we can have ls kind of stuff here. Same, everything is same. This we are in the HDFS kind of stuff now. Okay.
Okay.
Now there is a command called spark-shell. Okay.
Okay.
Suppose just I want to create the one directory called now. How to create the directory here? mkdir.
Yes,
Okay.
Sridhar.
mkdir teja. I am creating one directory called teja. ls teja is there? Yes, teja. Now cd teja. Okay, I have created the directory called Teja.
Yes,
Okay,
sir.
now just to get the Spark, to get the Scala and Spark integratedly, we need to execute the command called Spark Spark hyphen shell.
Okay.
It takes us, this command takes us to the onto the Spark engine with Scala scripting language.
Okay, sir.
See, earlier also we have type hive hyphen something, then it will prompts us the hive greater than means hive shell, right?
Yes, sir.
HBase also HBase shell. For scoop also MySQL shell, right?
Yes, sir.
In the same way, Spark shell command takes us to the Scala shell.
Okay. Same thing like
Where
that.
it is where links to the this one Spark engine.
Okay, sir.
So what we need to do is just Spark hyphen shell.
Okay, sir.
Any confusion or any shall I?
No, no, no. Continue, sir.
So Spark hyphen shell, just because already Spark is installed in this VMware Teja. That's what.
Okay.
Spark is readily installed in this one. So here it is not installed. That's what I
In
did. I
your
am not.
Cloudera.
This is I have downloaded from the Cloudera website.
Okay, Sridhar. Okay, okay, okay.
They have prepared one VMware with all the components.
Okay, Sridhar. Got it.
Already you have also downloaded it, I think.
No, 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 Sridhar. Not yet.
Okay, just go to the Cloudera site. Otherwise, just Google it. Cloudera Quick Start VM 5.7.0 download. You will get it
Okay, Sridhar. Got it.
just from the Cloudera website. Those Cloudera people have prepared the VM with all the components, including Spark and Scala.
Okay.
Just what we need to do is we need to use it. That's it. Like this. How I am using.
Okay.
Cool. Now Spark shell, just enter. Now it will takes us to the Spark and Scala prompts. It will take time.
Okay, Sridhar.
So slowly it will take. See, what is the version they have deployed here? Spark version 1.6.0.
1.6.0. Okay. Nice. Okay. Is this free, Sridhar? This Cloudera?
Whatever we are doing now, it is a free
Okay, Sridhar. Open source.
open source.
Okay. Scala is also built in Java, Sridhar?
Yes, correct, correct.
Spark Shell.
Okay. Now we reach Teja.
Yes, yes.
See, Scala.
Yes, Sridhar. Just like every other pig and all.
Pardon?
Just like pig, you did pig shell and you got.
Correct, 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 correct. Like that, high, wow, H base, like that, Scala.
Yes, yes.
Okay. Now here we can write our programmings. We will just do the some programming and okay, all these things. Programming shall we see tomorrow, Teja?
Okay, Sridhar, no problem. I think it's
Yeah.
getting late too.
Entire main basic concept programming means thing I will tell you tomorrow. Hello.
Yeah, Sridhar, yeah, yeah, yeah.